Hi, so today we'll be solving problems involving Coulomb's law and superposition principle. So as a reminder, Coulomb's law states mathematically that Fe is equals to K absolute value of Q1 times Q2 all over R squared, wherein K is equals to 9 times 10 to the 9th power. And the superposition principle states that each charge will exert a force on another charge as if no other charges are present. Okay, so we'll be talking about problems wherein there are points arranged in a linear position, and these points will be having identical charges. Okay, so for our first problem, we have points A, B, and C, wherein they have the identical charge 4, and we will be solving for the force exerted by A and C on point B. So let's start. So according to the superposition principle, we should take this one by one. So first, we will focus on the force exerted by A on B. So let's have force exerted by A on B. So we'll be using the Coulomb's law formula, which is K Q1 Q2 over R squared. Then let's now input the values. We have 9 times 10 to the 9th. Then Q1 will be A, so that's negative 4, times Q2, which is B, so that's negative 4, all over. R will be the distance between the two points, so that's 3. We'll put 3 squared. So then now we'll simplify that, and we'll have 9 times 10 to the 9th. Then we'll have 16 over 9. So when we input that into our calculators, we will get 1 times 1.6 times 10 to the 10th power. So then now we need to figure out which direction this is going. So we have to remember that when we have points which have the same sign, in this case they're both negative, that's negative A and negative B, these points will then be repelled from one another, so meaning they will be moving away from each other. So in this case, A will move away from B to the left, while B will move away from A toward going to the right. So now we know that B will be going to the right when we consider the forces exerted by A. So now let's go to the next charge. Let's now focus on C. So we'll figure out the force exerted by C on B. So we'll use the same formula, K Q1 Q2 over R squared. So let's input values. That's 9 times 10 to the power of 9. So Q1 now is negative 4, that's B. And then Q2, that's positive 4, C. And then the distance between them, 5, so that's 5 squared. Then let's simplify that, and we will get 9 times 10 to the 9th. Then this is negative 16 or 25. Since this is absolute value, so we can change that to positive 16 over 25. So now So now let's put that into our calculators, and we will get 5.76 times 10 to the power of 9. So going back to the drawing, we see that B and C have opposite signs, which means they will be attracted to one another. So meaning C will be moving towards B to the left, and B will be going towards C to the right. So this is also to the right. Let's place right. So now we will be looking for the resultant force. That's F resultant. So we will now combine the force exerted by A and the force exerted by C. So we have 1.6 times 10 to the 10th, so that's positive since it's going to the right, plus, again positive, 5.76 times 10 to the 9th, and we will get 2.176 times 10 to the 10th. So this is now our final answer. So let's solve another problem. Let's see. What if we have point A, B, and C again, but this time we'll have different values. Let's say that the distance between here is 2 and this is 1, and the value of A is negative 2.89. The value of B, let's say positive 2.89, and the value of C will be positive 2.89. So now this time let's try to figure out the forces exerted on C. So again, we go back to the formula. Fe is equals to K Q1 Q2 all over R squared. So first, let's focus on the force exerted by A on C. So force exerted by A on C. So let's input values. That's 9 times 10 to the 9th. Then Q1A is negative 2.89 times C, which is positive 2.89 all over. So the distance between them, it's total of 3. That's 3 squared. Then let's simplify that, and we will get 9 times 10 to the 9th, 8.3521 over 9. Simplifying that further, we will get the answer of 8.3521 times 10 to the 9th. So now let's figure out which direction it will be going. So we have A, which is negative, and C is positive, so meaning they will be attracted to one another. So A will move towards C and C will move towards A, going to the left. So let's put here left. Okay, then let's move on to the next, which is B. So let's look into the force exerted by B on C. So still the same formula, so let's put 9 times 10 to the 9, and then the value of B, which is positive 2.98. Take note that this is the absolute value. That's why even though the answer to here is supposed to be negative, but because of the absolute value, this is not negative. Instead, it's becoming positive. So anyway, back to the force of B on C. So that was 2.98 times C, which is also positive 89. So sorry. 89. Okay, yeah. And then the distance between B and C is 1. So that's 1 squared. Then we'll simplify that, and we will get 9 times 10 to the 9 times 8.3521, and then simplify further, we will get 7.51689 times 10 to the 10th. So now let's figure out which direction it's going. So we see that we have positive and positive, so meaning they will be going away from each other. So B will be going to the left, while C will be going away from B to the right. So this is right. So now let's look for the resultant force. So that's 4. So let's put, I just want to put the positive first, so right. So that's 7.51689 times 10 to the power of 10 plus, so since this is going to the left, this will be negative 8.3521 times 10 to the 9th. So we will get the resultant force 6.68168 times 10 to the 10th. So now this is our final answer. And yeah, this is going to the right because it's positive. So yeah, I hope you guys understood that, and look into the other videos for more explanations. And if you have any questions, clarifications, just comment it down below. Thanks.